Hello, this is Mr. Mac. This is a concept video on the graphs of the trigonometric functions. Now it seems to me like we're probably going to need to have 2 or 3 videos to get all of this done, but we'll at least get started. So what we'd like to do first is we would like to graph y is equal to the sine of theta. Now, earlier I showed you how to figure out the sines of special angles, and I'm going to just make use of those facts, and you may need to pause the video from time to time to take a look at the values and to check to see that the values are right, but I'm going to go ahead and just do this, and you need to watch and see that these are actually the points. Now, the sine of 0 degrees is 0, so the first point on our sine graph would be the origin of 0, 0. The sine of 90 degrees is 1. The sine of 180 degrees is 0. The sine of 270 degrees is -1. The sine of 360 degrees is 0. The sine of 450 degrees is 1. The sine of 540 degrees is 0. The sine of 630 degrees is -1. And the sine of 720 degrees is again 0. Now, this actually looks like just maybe the teeth of a saw or something like this, but the graph actually is kind of a smooth curve. We call it a sinusoidal curve. This point right here on the x-axis would be about 45 degrees. And if you recall, the sine of 45 degrees was the square root of 2 over 2, which is about 0.7. So we would have this point here and this point here, and then down here it would be -0.7 and -0.7. So if you were to draw a smooth curve of the sine graph, the first period would look something like this, and then it would repeat that same cycle over and over again. So the sine graph will look something like this. Now, it's kind of important that this shape become meaningful to you. This is the sine graph, and there's a number of features of this that you probably need to recognize. First of all, one period or one cycle of the graph goes from 0 to 360, and then it just repeats that same cycle over and over and over again. The height of the graph, the sine graph, is 1, and the bottom of the graph is -1. So all of the sine graph is between -1 and 1. And the period is 360. I think I said that. Okay, now, you need to be able to realize that this is the shape of the sine graph. Now, what they're going to ask you to do is they're going to ask you to be able to do some things with transformations of these graphs. So first of all, let's name a couple of things. The first name I need to give you is amplitude. Now, the amplitude is basically the distance from the center of the graph up to the top, or from the center of the graph down to the bottom of the graph in the sine and cosine. Now, on the basic sine graph and on the basic cosine graph, the amplitude will be equal to 1. Now, from our work on transformations, you should know that if, for example, we multiply this function by, say 2, then we would get another function, let's say y equals 2 sine theta, and the graph of y equals 2 sine theta would look like this. Oops. Let's try to do a little bit better job here. Now notice what happens is that this is a vertical stretch, and the width of the graph stays the same, but now the amplitude is 2 rather than 1. So students learn that the coefficient in front of the sine or in front of the cosine is the amplitude of the graph, and that's the distance from the center line of the graph to the top or the bottom. Now, you also need to understand about the period. If we were to write, let's say y is equal to sine 2 theta, do you see what we would be doing here is we'd be multiplying by the input, theta, by 2 before we actually take the sine of it. And if you recall, what that does is that's a horizontal compression, so y is equal to sine 2 theta would actually shrink this graph so that it looked more like this. So one complete cycle of the graph would be from 0 to 180, and then it would do that over and over and over again. Now, of course, if we said y is equal to sine of theta plus 2, what that would actually end up doing is moving the whole graph up 2. Now, to move the whole graph up 2, what I did, because it's a whole lot easier, I moved the x-axis down 2. But notice now, y is equal to sine of theta plus 2, the graph has been shifted up 2. So all of the transformations that you knew about the graph actually work. But truthfully, what's really important is that you know that the basic shape of the sine graph is this sinusoid. Let me see if I can go ahead and just do this again for you. Put a little too much in there perhaps. So this is 90, 180, 270, 360, 540, 630, 720. Okay, so the basic sine graph starts at the origin, and it does this. And it repeats that over and over and over again. Now, the basic cosine graph y equals cosine theta starts at 1. Cosine of 90 is 0. Cosine of 180 is -1. Cosine of 270 is 0. Cosine of 360 is 1. And 0 and -1 and 0 again. So the cosine graph looks like this. Now, it turns out, this is really kind of intriguing, I think, that the cosine graph is the sine graph shifted 90 degrees to the left. So sine graph looks like this, cosine graph looks like this. If we shift the cosine graph to the right 90 degrees, we get the sine graph. So both the cosine and sine graphs look like this, and they both transform in pretty much the same way. Their amplitude is 1 and their period is 360. Now, the next graph we want to talk about is the graph of the tangent. So let's see if we can get this stuff off of our screen here that we don't want now. Oops, no, that needs to stay at this point. Yeah, there we go. All right. Oh, and this needs to go away. There we go. All right, so now we're looking at y equals tan theta. Now, let's renumber these things a little bit here. The tangent of theta has a period of 180 instead of 360, so it makes sense to do 45, 90, 135, 180, 225, 270, and so on like that. Now, the tangent of 0 is 0. The tangent of 45 degrees is 1, And the tangent of 90 degrees is undefined. Now, one of the things that we've learned a little bit, and you'll learn more in the future, is that when a function is undefined, ordinarily that represents a vertical asymptote for the graph. So notice I've put a vertical dotted line in at 90. Now, the tangent of 135 is -1. The tangent of 180 is 0 again. The tangent of 225 is 1, and the tangent of 270 is again undefined. So I'll put another one in here. And let's go on the other side a little bit. Here's -45 degrees. Here's -90 degrees. The tangent of -45 degrees is -1. The tangent of -90 degrees is undefined. Now, the tangent graph then looks like this. And it does that over and over and over again. Now, nobody else does this, but I like to refer to the points that are halfway between 0 and undefined as the amplitude point. Now, see, at the tangent of 45 degrees, the tangent of 45 degrees is 1. So if I had y is equal to 2 tan theta, then at 45 degrees, I'd be at 2 because tangent of 45 be 1 and multiplied by 2, you get 2. So whatever the coefficient is in front of the tangent, that's where this point, I'm going to call it the amplitude point. That's where that amplitude point is going to end up being. And again, we can shift these things vertically, horizontally, stuff like that. And so there's the tangent graph. All right, now let's take a look at the secant graph. Or actually, I guess we're looking at cosecant first. If y is equal to the cosecant of theta, one thing I will point out is that the cosecant of theta is the reciprocal of the sine of theta. So that's the same thing as 1 over the sine of theta. Now, let's just draw in a sine theta graph here. Maybe I should do this as a, well, I'll do it as a dotted line, but what I'll do is I'll sketch it in and then I'll have the smartboard make it dotted for me. How's that? And again, this is 90, 180, 270, 360. No, can that be right? That's not a sine graph, that's a cosine graph. Here we go. Oh, the degrees went with it. I got to take care of those. There we go, 0, 90, 180, 270, 360. Yeah, this makes more sense. All right. Now, what we want to do is we want to graph the cosecant of theta, which is the reciprocal. The cosecant is the reciprocal of the sine. Now, if we do a couple of things, we can kind of help ourselves out here. Y is equal to cosecant theta. Let's just turn this red. Okay, now I'm going to use the red pen for the cosecant of theta stuff. When the sine of theta is 0, its reciprocal is going to be undefined. So we get a vertical asymptote at 0. We get a vertical asymptote at 180. We get a vertical asymptote at 360. We get a vertical asymptote at, I think that's 450, and so on like that. Now, let me point out also that the sine of 90 degrees is 1. The reciprocal of 1 is 1, so the cosecant of 90 degrees would also be 1. Now notice we asymptote, we're not going to get 0 here, so we asymptote to this direction and to this direction, so we get the cosecant graph. Cosecant graph asymptotes to the asymptote here and to the asymptote there. Now, the sine of 270 degrees is -1. Now, the reciprocal of -1 is, again, -1. And so we're going to get a piece of the cosecant graph, and it's going to go down this way. It's going to asymptote to the asymptotes again from -1. And then the sine of 450 degrees is 1 again, so we're going to get another one of these. So notice we have these, oh, I forgot to do this. Hang on just a second here. There we go. No, that didn't work real well. Let's make it the bigger dotted lines. There we go. Okay, so notice the dotted sine graph gives us kind of the anchors that we can use to draw the cosecant graph. Where the sine graph is 0, the cosecant graph has asymptotes. Where the sine graph is 1 or -1, the cosecant graph matches up with that, and then it asymptotes. So there's the cosecant graph. All right, now the secant graph works pretty much the same way. You might want to pause the video here and try this one yourself. Okay, hi, welcome back. Now let's do the secant graph. So with the secant graph, we're going to first start out with y equals cosine theta. And remember, that was 1 and 0 and -1 and 0 and 1 and 0 and -1 and 0. And so we have a cosine graph that looks something like that. Now, at this particular point, let's just go ahead and make that dotted. There we go. Now, when the cosine is, okay, now we're doing y equals secant theta. And the secant theta is the reciprocal of the cosine. So when the cosine is 1, so will the secant be. When the cosine is 0, we will get vertical asymptotes. So we could just draw in the vertical asymptotes where the cosine graph crosses the x-axis. Now, so we have 1 here and we go to the asymptote. We have -1 here and we go to the asymptotes. We have 1 here and we go to the asymptotes. And -1 here and we go to the asymptotes. So this green graph is what the secant graph looks like. All right, one more to do, the cotangent. The cotangent is the reciprocal of the tangent. So if we have y equals tan theta, and let's see if we can reproduce that graph. We had 0, 45, 90, 135, 180, 225, 270, 315, 360. Okay. Now the tangent graph had asymptotes at 90, -90 of course, and 270, and it looked like this. Now let's go ahead and make that dotted. Okay, now, since the cotangent, y equals cotan theta, is the reciprocal of the sine of theta, wherever we have a 0 for the tangent, we're going to have an asymptote for the cotangent. So we've got an asymptote here, and an asymptote here, and we actually have another asymptote over here at 360. I probably should have drawn a little bit more. Now, when the tangent graph is really close to 0 but positive, the reciprocal is going to be very big. And so the reciprocal of 1 is 1, and at 0 here. So what we're going to do is we're going to get something that looks like this, and then here's another one. Oops, should have gone through this point right here, should have gone through there. I'll just make the point really big. And so there is the cotangent graph. Now, that didn't take as much as I had expected, but they are going to expect you to be able to draw these graphs and to transform them in certain ways. So practice some. As they say, how do you get to Carnegie Hall? Practice, practice, practice. All right, and we're done.